Bismillahirrahmanirrahim. With the name of Allah, who is the most beneficent and merciful. Today we are going to discuss a topic from mechanics of solid. But before going to the topic, we have a clear concept of this subject. In mechanics of solid, we discuss about the stresses produced in the members that are against the applied loads. And what is stress? Stress is the resistance of the material to the applied loads. And what is load? Load is it's something which will change the shape of the object is called as load. So now, in this subject, we will discuss these two phenomena, load and stresses in the members. So today we are going to discuss moment of inertia of different figures. So before going to the derivation, we have a clear concept of moment of inertia. Moment of inertia is actually it is a phenomena in which the area dA, we named it dA, the area and distance, scale of distance from the corresponding axis. It is a product of area and the scale of distance from the respective axis and extended it by taking integration. If we write the formula of moment of inertia about a circle or any figure, then it will be equal to, for example, we are going to deal with an ellipse. This distance is A and this is B and this is the x-axis, this is the y-axis. If we write a formula of moment of inertia for this ellipse, then if we are taking the corresponding axis as x-axis, then it will be equal to ix is equal to integration y square into dA. dA is the area of each element in the figure and it is multiplied by the scale of distance from the axis, and then it is integrated to enhance the area. Similarly, if we write the formula for moment of inertia about y-axis, then it will be equal to Iy integration x square dA. So these are the formulas for moment of inertia of any figure that we want to calculate. But today we are going to calculate the moment of inertia of a rectangular about its base axis. The moment of inertia for the rectangle, consider a rectangle. This is the axis, x-axis, and this is the y-axis. Consider a rectangle of h depth and its width is b. Now just consider a small strip of thickness dy and the height of strip from the axis is y. And we know the general formulas of moment of inertia of various figures about the principal axis. The moment of inertia for rectangle about principal axis is Ix is equal to bh cube divided by 12 and Iy is equal to hb cube divided by 12. Similarly, for circle, it is equal to Ix is equal to pi r raised to 4 divided by 4 and Iy is equal to pi r raised to 4 divided by 4. And it is for circle, it is for rectangle, and if we we can also given the moment of inertia of about the principal axis of ellipse, also the triangle and other figures. For ellipse, it is its value is pi ab cube divided by 12 and Iy is equal to pi ba cube divided by 12. So these are some examples of moment of inertia about the principal axis that we also calculate, but here we have given, and our target is to calculate the moment of inertia about the base axis. We are not going to calculate it about the principal axis. we can calculate the moment of inertia about the base axis by two methods. One method is by parallel axis theorem and the other is from definition. So we will discuss both of them, but first of all we will discuss parallel axis theorem. Parallel axis theorem states that if we know the moment of inertia about any axis, then by using this formula we can transform the given moments about any required axis if we know the distance between the two axes. So the formula for parallel axis theorem is Ix is equal to Ix bar. This is the moment of inertia about the principal axis plus AD square. A is the area of that figure and D is the distance between the two axes. So if we calculate moment of inertia of this specified figure, then Ix will be equal to Ix bar, and I have just write the value for Ix bar about the principal axis. This is equal to BH cube 12 plus the area of this rectangle is B into H, and then the distance the principal axis is somewhat here with the position of approximately the mid of height and the mid of width. So, and we have given the moment of inertia about this axis. This is the principal axis, which is passing from the centroid, and we are going to calculate it about the base axis. So the distance between these two axes is D, and D is equal to half of H, and it will be equal to H by 2 square. BH cube divided by 12 plus BH cube divided by 4, that will be equal to 12, 3 BH cube So this is a moment of inertia about x-axis, and it is equal to bh cube divided by 12. Similarly, if we calculate moment of inertia about y-axis, then it will be equal to hb cube divided by 3. It is a moment of inertia of rectangle about this specified axis. This is the first method. We can also calculate moment of inertia of this figure about x-axis and y-axis by using the method of definition. So from definition we know that moment of inertia is equal to, if we calculate Ix, then it will be equal to integration y square into dA. So if we calculate for this rectangle, then Ix will be equal to limit, and the height of this whole rectangle is 0 and this is h, so it will be equal to 0 to h, y square into dA. dA is the area of this strip and it is equal to b into dy. D is constant, dy is equal to b by applying integration. By putting the values of limits. So it will be equal to bh cube divided by 3. Ix is equal to bh cube divided by 3. This result is same as that of previous. So by using any one of method we can calculate the moment of inertia of this figure. Not of this figure, but also we can calculate the moment of inertia of triangle, circle or ellipse, any figure whose the moment of inertia about the principal axis we have given then we can calculate it by parallax theorem. If we don't know the moment of inertia about the principal axis, then we will calculate it by using the method of definition. So this is all about the moment of inertia about rectangle. That was our topic. Thank you.